We can look as well at the nitrogen and water cycles in some detail to see what happens to the landscape of the Lion King, or more accurately, in a variety of real life conditions. It's very straightforward when you consider that nitrogen cannot be taken up by living creatures directly from the air. This is a bit puzzling considering that it constitutes the majority of our atmosphere and it is a crucial feature of proteins, and yet we can't get it. We're swimming in it, we can't get it. The only way that living creatures of our size end up getting nitrogen is through a long series of steps that begins with nitrogen fixation in the soil by bacteria, uptake by plants, and then the availability via the plants to a variety of other creatures. The cycle doesn't always go back to the atmosphere. When we talk about the nitrogen cycle, typically we're talking about living beings dying and the nitrogens being present in chemical forms through the soil being taken up by bacteria there and becoming available again. So nitrates are a very crucial kind of cycle because the cycling that's most relevant to us is indeed carried out through the presence of living beings. It's also important in terms of water availability. Water can flow rapidly through an area or it can be collected in an area. Whether the ground is flat or whether the ground is tilted is the obvious primary variable, but the other variable concerns the number of living creatures there. Life is aquatic. If you are alive, then you're full of water, and clearly the nitrogen contained in your body is going to be associated with that water. Also, groundwater is a chief repository of nitrates. So therefore, the amount of living beings in an area contributing to the soil of the area and the amount of water that's present without running through the area rapidly, all of these contribute to a buildup of nitrates in an area, which in and of itself is a primary resource for the amount of life that can be there. All of which to say is when a landscape turns into this blasted, wasted, desiccated kind of situation through an ecological impact, it's because water is running out of that area much more rapidly than it used to, taking the nitrates with it and instantly diminishing the pure amount of biomass that can be there. This has nothing to do with which predator happens to be eating the antelopes, or indeed whether the predators are eating up all the antelopes or anything of the kinds. None of that is going to affect the amount of nitrates that can be retained in that area based on plain old physics.